Hi all, good morning. Today we will see the concepts of extreme values. And we are given with the function f of x comma y equal to y square minus x square. And now we are supposed to find the extreme values. That means whether it attains the maximum or minimum. We are going to check that. So we are given with f of x comma y equal to y square minus x square. So let us find the partial derivative of f with respect to x, which is minus 2x. And also we are finding partial derivative of f with respect to y, which is plus 2y. Now equating it to 0, we are getting the critical points here. So minus 2x equal to 0 implies 2x equal to 0, and 2y equal to 0 implies y equal to 0. So we get 2 points 0 comma 0, and let us keep that points. And also we will find the second derivative because we'll go with second derivative test here. So from fx you find f double x, which is going to be minus 2 because we're differentiating minus 2x with respect to x again, which is r. And when you differentiate fx with respect to y, it's going to be 0. You can do in either way. You can differentiate f with respect to x, that will also give you 0, or fx with respect to y, that will also give you 0. So s is the mixed partial derivative here, right? All right. And your t value, which is going to be second derivative of f with respect to y, that is f double y. So you're differentiating fy with respect to y, which is 2. So finding d, which is rt minus a square, so it will be minus 4. Minus 4 is a negative quantity, so it is less than 0. So if you have d less than 0, then this point 0 comma 0 f will be a saddle point. That means f of 0 comma 0 is not a local maximum or a minimum. Now the only critical point here is 0 comma 0, and this point will tell us that it will not be a maximum or a minimum. So note that for the points on x-axis we have y equal to 0. Therefore when you substitute in the problem y to be 0, in the question, then f of x comma y is minus x square, which is less than 0, where x is not equal to 0. And however, for the points on y-axis we have x equal to 0. So f of x comma y equal to y square. When you substitute x equal to 0 in your question, then that will give you y square, which is greater than 0, and y not equal to 0 here. So why do we want to work with these steps? The reason is every disk with center 0 comma 0 contains points where f takes positive values as well as points where f takes negative values. So based on the axis, if you see in x-axis, you're getting f of x comma y to be negative. In y-axis, f of x comma y to be positive. So in this case, what happens is you cannot determine whether it is a maximum or minimum point. Therefore, f of x 0 comma 0 will give you 0. So which will not be an extremum value. That means this will not be a maximum value or this will not be a minimum value. So f has no extreme values. So how do we visualize it? You can see here. So again we are telling 0 0 is a saddle point here. So what do you mean by saddle point? So saddle point is a point where this function will not attain the maximum or minimum at that point. So you can visualize this. You can see at one direction you can see the point to be minimum. At opposite direction, that means from the bottom, if you can see the point is in maximum position. So you have the origin, which is 0 0, which will be forming a saddle. That's why it is called as a saddle point. Thank you.